Okay, very good. What you get when you multiply these is x plus 3 times x minus 1, numerator times numerator. Of course, you need parentheses around those. Denominator times denominator. Now, when we multiply these, we want to use the distributive law, not some trick, not this and this and this and this. Okay, I'm going to use the distributive law. I want to see it written out because we're going to need it when we get the bigger expressions. So isn't it tricky? I mean, it's not a trick. It's just a straightforward application of the distributive law. X plus 3 times x minus 1 is x times x minus 1 plus 3 times x minus 1. Okay, that's all we write in the first step. We'll simplify that in the next step. Because you've got to apply it twice. Then you've got to apply the distributive law to each of these. Here we have x times x plus 4 minus 2 times x plus 4. Okay? This equals x squared minus x. X times x is x squared. X minus 1 is x. 3x plus 3x minus 3 over x squared plus 4x minus 2x minus 8. Okay? I'm sure you see where all that comes from. Make sure you write it out like this. Okay? If you want to do something else off to the side to check yourself, go ahead. But this is more reliable and easier to remember ultimately. Okay, so you have x squared plus 2x minus 3 divided by x squared plus 2x minus 8. Okay? Now, does that reduce? Well, to see if it reduces, you have to factor this and you have to factor this. Okay? Helping factors pretty easily. Yeah, I'm going to leave myself enough room. Never do. Okay, my trademark? Not really. It's an unfortunate consequence if I think about one thing while I'm doing another. Okay, so anyhow, that's x plus 3 times x minus 2. Okay? Divided by what? Well, now, if I set this numerator equal to 0 and solve the equation using the quadratic formula, I'm going to get x equals negative 3 and x equals 2. Because this is 0 when x is negative 3 or x equals 2. Okay? So the quadratic formula will actually tell me down here whether I can factor this thing. I just set it equal to 0 and see if I get integer or rational results. Now I'm not going to actually do that. You know how to do that. We're going to get the discriminant is going to be 2 squared minus 4ac, right? And 4ac is 32, so it's going to give us 36. Okay? Which means that, yeah, I'm going to be able to factor this. Okay? And you can even tell what the factors are from the quadratic formula, and that's not what I'm trying to do right now, but do that as x plus 4 times x minus 2. And look at that, x minus 2 is a common factor. So we can say this is x plus 3 over x plus 4 multiplied by x minus 2 over x minus 2. But what's x minus 2 over x minus 2? 1. So that's just x plus 3 over x plus 4. Okay? Now, I really didn't expect this. I just made this up off the top of my head. I really didn't expect it to reduce. I really expected when we did this, we get the square root of something that doesn't have a whole number square root. Okay? In which case, we wouldn't be able to factor on integers and rational numbers. In which case, nothing would have reduced. In this case, just coincidentally, something did. And you got to always check that, and that's why. Okay, you can't just leave it like this because you're not sure that's in lowest terms. Does that make sense?
Yeah.
Okay. Okay, very good. Now, over here, what we do is we say that this is equal to x plus 3 over x minus 2 plus x minus 1 over x plus 4. And then, to make the denominator the same, we do exactly what you did. Multiply this by x plus 4 over x plus 4. Multiply this by x minus 2 over x minus 2. Okay? Well, we do that. And just to emphasize the distributive law, I'm going to write every dang one of these out using the distributive law. I'm sure you can do it, but I want to emphasize that's what we need to do. And also emphasize it for people who will get to watch the videos, okay? And I don't know, I'm rewriting the same thing I've got there because I wasn't talking. And that's not the way to do another step. Okay, so x plus 3 times x plus 4 is x times x plus 4 plus 3 times x plus 4. And x minus 2 times x plus 4 is x times x plus 4 minus 2 times x plus 4. No, there actually wasn't writing out what I started to write out, where I just put parentheses around this and parentheses around this and everything. I think we understand that. I hope so. So this is, the numerator is going to be x minus 1 times x minus 2, denominator x plus 4 times x minus 2. Same thing here, so put the parentheses in here to make sure we understand it. Okay, so x minus 1 times x minus 2 is x times x minus 2 minus 1 times x minus 2 over x plus 4 times x minus 2. Well, then that's going to be x squared plus 4x plus 3x plus 12 divided by x squared plus 4x minus 2x minus 8. And then that's plus x squared minus 2x minus x plus 2. And this is x squared plus 4x minus 2x minus 8. And just, taking it slowly. Not in a hurry to do this. This gives us a 7x here, right? And the x squared and the 12. And this gives us minus 3x. Along with the x and the 2. And this, of course, comes out the same as this because that was our goal. Okay? And this equals then since you have the same denominator, now you can just add the numerators. Okay? And when we do that, it's easy to see that we get 2x squared, and we get 4x, and we get 14. And here we get x squared minus 2x minus 8. Now this x squared plus 2x minus 8 is the same thing we got up here, so we see that factors. We've got to check to see if the numerator factors. Okay? Our discriminant is going to be 16 minus 56, not actually minus 112. Your minus 4ac is going to be really big here, giving you a negative under the radical. If you try to set this equal to 0 and solve, which means there's no solution. This number here is always positive and it doesn't factor, okay? So whether you understand that completely or not, we'll kind of go over that in class. That's not something I expect you to know by now, so I kind of wave my hands over it. I said it right, okay? Discriminant is negative, so you have no solution with the quadratic equation. So a graph of this thing would never go through 0, and it does never go through 0, you can't factor it. Okay? And we'll see in class. So anyhow, this is in lowest terms. Okay? So we could leave it like this. Or if we want, we can factor the denominator depending on what we intend to do with this expression. Okay? In general, we'll factor it because that tells you where the denominator is 0, and that tells you what values of x make the denominator 0, tells you what values of x can't be in the domain, because you can't have a denominator of 0. You can't divide by 0. Okay? As we've mentioned with wanting 10 apples, never getting any apples, so we never have an apple. So we can't divide 10 by 0. Meaningless. Okay? Make sense? Okay, you did pretty well with this. So I think when we get the rational functions, set this thing about how you graph this sort of thing, which will bother everybody. Shouldn't bother you any more than it does. It probably bother you less than it does a lot of other people that are a little shaky on this. Okay? So I think you're in pretty good shape. Hopefully nobody's shaky on it, but I'll bet you statistically out of a class of 12 people, somebody's going to be shaky.
Yeah.
Can't tell you who. Everybody seems to be doing kind of okay to very well, you know. But we'll see when we get some tests. Okay? Okay, so there we have it. Okay, well, that's very good.